Now we're going to get into the calculus of lesson 5.5. So we can break it up into two parts. We're going to start by looking at exponentials of different bases and how those derivatives work. And then we're going to switch to logarithms of different bases and see how those work. And I love to compare it with something you already know. It makes it much easier to remember. So if you're deriving an a to the x, you're going to still get the original. So think about the derivative of e to the x. I'm going to compare it to what you already know. The derivative of e to the x was e to the x. We said it was like the easiest derivative. The only difference if you're deriving base a to the x is it still is a to the x, but then you have to multiply your answer by the natural log of the base number. Here's why that wasn't necessary here. If you multiply that by the natural log of the base number, the natural log of e is 1. So it was unnecessary because it would just cancel away. If you're deriving an a to the u, so let's remind you how we did it with e to the u. So the derivative of e to the u was the original e to the u times the derivative of the exponent, the derivative of u. If you're deriving a different base, it's still the original, it's still the derivative of the exponent, but then we have this additional natural log of a. Again, the reason I didn't need it here is that would be a natural log of e, which is 1, and it cancels. I'm going to take you through 4 examples. Anytime this is presented on an AP test, it's usually incredibly straightforward, so we're not going to spend a ton of time looking at really complicated ones. So the derivative of 5 to the x is 5 to the x times the derivative of x, which is 1, times the natural log of the base number, which in this case is the natural log of 5. And that's it. Second one, also very straightforward. You have the original exponential, 4 to the 2x plus 1, times the derivative of the exponent, times the natural log of the base number. All of those things are being multiplied, so as long as you have them all written, it doesn't matter the order that you write them. We can see this new rule combined with other previous derivative rules. So as you can kind of expect, I really like to relate things to product rules and quotient rules. So that's what we've got here. This first one is a product rule. So first times the derivative of the second, the derivative of 3 to the x squared is the original 3 to the x squared, times the derivative of x squared times the natural log of 3, plus second times the derivative of the first, 3 to the x squared, times the derivative of x squared, which is 2x. And I wouldn't even spend time simplifying it. I would just make sure I have all the pieces that I needed to derive. And then the last one of this type is a quotient rule. So bottom times the derivative of the top, which is the original 7 to the x, times the derivative of x, which is 1, times the natural log of 7, your base number, minus top times the derivative of the bottom, which is going to be 7 to the x times 2x, all over the bottom squared. So that is your next new rule. We're almost to the end of the road as far as new derivative rules, but that gives you another one to work with.